All right, welcome. These are the notes for section 4-1. This is the back side of the notes page. We've got a few problems here to do. We're going to go ahead and jump right on in, try to get through this as quickly as we can. Number 4, we have the quantity of 2y minus 3 times the quantity of y minus 2 equals negative 12y plus 18. With this one, we can tell this is going to be quadratic because when we multiply the two binomials together, we're going to get a y squared term. So let's go ahead here and simplify the left side by multiplying it out. So we're going to do 2y, we're going to distribute it through, and then distribute our negative 3 through. When we do that, we should end up with 2y squared minus 4y minus 3y plus 6. Combine our like terms, we have 2y squared minus 7y plus 6, and that still equals negative 12y plus 18. Because this is quadratic, we want to make sure that we set it equal to 0. So we're going to take this here and we're going to add 12y to each side. We're going to subtract 18 from each side. We have 2y squared plus 5y minus 12 equals 0. Now we need to factor, and you can go ahead and pause the video if you need to take a second to factor it. I'm going to go through and factor it for time's sake. Nobody wants to listen to me any more than they have to. So when we factor this, we should end up with a 2y and a y. We should have, let's see, a 4 factors of 12. One has to be multiplied by 2. So we should have 2y minus 3 and y plus 4 after you factor it. Like I said, you can go ahead and take your time, factor it, pause the video if you need to, and then come back and check it. But we're going to set each of those equal to 0. Using our 0 product property, we're going to end up with y is going to equal 3/2 and y equals negative 4. Now each of these can be checked by plugging them back in. I've already checked them, and for time's sake here, I'm going to tell you that they both work out. Now number 5, we have kind of a special case here. We have the quantity of x plus 2 squared plus 4 times the quantity of x plus 2 minus 5 equals 0. There are several approaches you could take to solve this one. One thing you could do here is you could go ahead there and simplify the left side, and what I mean by that here is multiplying out the x plus 2 times the x plus 2, which would be x squared plus 4x plus 4. Distribute the 4 through our middle quantity there, so we'll have plus 4x plus 8, and then minus 5 equals 0. Now we can combine the like terms. We have a single x squared term. We have 8 x's. And then we have a 4 plus an 8 is 12 minus 5 is 7. So we have plus 7 equals 0. This factors into x plus 7 and x plus 1. So when we set those equal to 0, we get there that x equals negative 7 and x equals negative 1. Now, a second approach that can be taken to solve this is when we call this U substitution. Because we have the same quantity inside the parentheses here, it's being squared in one of them and it's raised to the first power in the other, we can say, hey, we're going to let u represent x plus 2, and we're going to substitute u in for those values. So what we would have here is u squared plus 4u minus 5 equals 0. Well, you can see the quadratic a little easier in this form without the actual quantities in there. We could factor that. That factors into u plus 5, and u minus 1. So we set those equal to 0. And you end up with u equals negative 5 and u equals 1. Now remember, we're solving for x. Those are just values for u. The next part of this then would be to take our statement that we said where u equals x plus 2, and we're going to take these values of u and we're going to substitute them in and solve it. So we should say here that negative 5 is equal to x plus 2. When we subtract 2 from each side, we get negative 7 equals x. Notice that was our answer up above. And the same thing with 1. We'll put 1 equals x plus 2. We subtract our 2 from each side, and we get that negative 1 equals x, which is also our answer above. Two different methods for solving the same problem there. Both work. Just thought we'd like to show you how the u substitution would work there. All right, let's move along here. We've got just a couple more quick ones to do. Absolute value, I know this is review. You did some of these in Algebra 1, but there's some stuff coming up with them in the second part of the chapter. So our goal here, again, when you're dealing with absolute values, is to isolate the absolute value. So here's what we're going to do. We have 4 times the absolute value of 8x minus 2, and that equals 8. So to get this by itself, we're going to go ahead and divide each side by 4. We now have the absolute value of 8x minus 2 is equal to 2. And just like on those earlier problems and from the first part of the notes, we're going to take out what's on the inside and set it equal to 2. And we're going to set it equal to negative 2. Those are the two values that are 2 units from 0. Oops, sorry there. Now we just finished solving. We're going to add 2 to each side, and we get 8x is equal to 4, which means that x equals 1/2. And you'll see here I made a little goof when I was writing that out. This should be 8x minus 2 equals negative 2. We add our 2 to each side. 8x equals 0, therefore x is going to have to be 0. And that's our second solution. So we get that x equals 0 and x equals 1/2. Looking at problem 7. The absolute value of 3 minus 7x equals negative 6. Well, hopefully you're paying attention here. There's an issue. There is no value you can take the absolute value of and get negative 6 or get any negative number for that instance. So this one is going to be no solution. You can add in there absolute value cannot equal a negative. All right, let's go on to the last one, number 8 here. If you want to pause the video and try to do this one yourself and check it, that might be a good idea. But you'll notice on this one, the absolute values are already isolated. There's nothing happening outside of the absolute value brackets on the left side of the equation. So that means here that, what's inside either has to equal negative 12 or it has to end up equaling positive 12. Those are the only two values that have an absolute value equal to 12. So we're going to take out our 5x plus 2. We're going to set it equal to 12. And we're going to take that 5x plus 2 and we're going to set it equal to negative 12 and we're going to solve it. We get 5x equals 10. And therefore x equals 2. Subtract our 2 from each side. We'll get 5x equals negative 14. And x equals negative 14/5, which you could also say is negative 2.8 if you want to. All right, that is the end of the notes for chapter 4-1 there. We're just reviewing ways to solve various types of equations. This will be important as we move forward and get into more complex equations in this chapter. If you have questions, make sure you mark them down, ask a teacher, go to Math Help, do what you need to do, and we will see you tomorrow.